There I am. Okay, so I'm presenting two projects, and some of you have been to these multiple times. So these are really updates on two projects I have previously presented. So I'm giving a little bit of background because I know there's a lot of people here who are new. So this first one is related to the reuse project that Jason showed, but really only minimally. It both preceded it and has an actual consequence. And I have to say that it's really more of a case study than it is a research project. And really nobody funded this project. This project came about because, well, the alley existed. And I just thought we had to reuse the material and not send it to landfill. So one of my MS students, 21, 22, Amanda Stanton, who's now working at SRG in Seattle, did her terminal project on analyzing what was there and what could be reused afterwards. In other words, this actually preceded the project that Jason was presenting, where they did a similar analysis of the bigger 10-story one. So she looked at two things. One was what was likely to be undamaged and what was also likely to be reusable after removing a lot of the big steel connections, and also which of the steel connections might be really usable. So in our architecture fantasy world, we imagine that these could actually just go into buildings. And you might think, why couldn't you just make a 3-story building out of the 3-story building? Well, it turns out there's no process for recertifying any of the stuff structurally now, right? There's been some proposals for being able to figure out how to recertify these things, but it doesn't exist yet. So really what we had to start looking at was non-structural applications. And I think my job was largely to find somebody who was willing to take this on. And I think maybe at one of these conferences a couple of years ago where I kept talking about this, some people actually got an idea about, maybe reusing this. So once the whole thing, this is actually a picture of it getting taken down. These things go up, but, and the 10-story, even more like this, it's an enormous amount of work to take these things down. There's a lot of embodied energy in that, as it turns out. And trying to find a reuse for it. And again, here you can see also these giant steel plates that leave giant bolt holes. So those parts are not so reusable. There's also these huge piles of metal that are left over, which again, we sort of hoped we could reuse in one way or another. We actually, Amanda did a design for a storage shed out back where we thought we could cut up some of the CLT panels and use them as beams. And anyway, it's a long story. It turns out none of that was really feasible. So the question is really what was feasible, and what's feasible is using it in non-structural applications. So Thomas Robinson from Lever Architecture, Lever has been involved with us in Reacts and lots of other things. After I talked to many, many people about the possibility of reusing the stuff, said, well, we could use it in Highland Hall. Now, some of you might know that University of Oregon is very sadly moving out of the White Stag building, and we're moving slowly. Architecture is part of the last piece of this, is moving to this new Concordia campus. It's actually an old campus that we're taking over. And this building, which I think served as various things, including a theater, on that campus, Lever was renovating for the architecture department. So he had this idea that they could use the panels in a non-structural way for various kinds of interior partitions. But there was a problem, which those of you who are familiar with public universities in this state might know, is that there is no money for this operation. And there's an incredibly tight budget for doing anything on this project. And so he said, the only way we can do it is if we can get all the fabrication donated. So I went to Ian and I said, wouldn't this make a great story that this was a project funded by ARS, and Andre and Ari were the leads on it, and then my student did an analysis of it, and it's going to become the architecture department anyway. And he was like, yeah, okay. So we did, and basically we donated Mark Gehrig's time to take all these panels and refabricate them. First, of course, drawings had to be done, examining the original panels, partly based on the work that Amanda Stanton had done to see what was available, and then to do files for their new installation, which is as low partitions, but also for some conference rooms in the space. And then Mark had to make those files into software of various kinds for our machines, DDX for our BSA, and had to then fabricate them, which is actually quite a long and laborious process. Here they are in process being fabricated, and there they are all labeled and ready. And then I think it's Howard S. Wright was the construction company that came, picked them up, and these were ready the way construction goes ahead of when Highland Hall was ready to take them. So they had to go store them someplace. But then, which we were very excited about, they started getting installed. And you can see here on the right, you can see these very flimsy normal interior partitions that are made up of, frame, and these nice solid 7¼ inch MPP pieces that are making up both low partitions and a conference room. And here it is, almost finished. These were taken a week or so ago. We hope it's finished soon because I think our students are moving in about a week. We think it is a kind of very exciting story. And some of the lessons are that we do need to develop some recertification processes if these are going to be reused structurally, which we hope they will. We don't anticipate that there's going to be a ton of mass timber buildings that are ready for deconstruction anytime soon, but at the pace that we're doing testing projects, there might be lots more testing projects that need to be repurposed. Anyway, so we're very excited about this project, and we'll all be able to see it because it's in a public building up in Portland very soon. Okay, so we also got several other people involved in this project. I got an email, I guess, from Professor Carl Hoppola I'm not sure I'm pronouncing his name correctly, over in mechanical engineering. He had a student, David Brown, who is here. David is here somewhere, isn't he? Yeah, there he is. Thank you, David. Right, and I'd actually been approached by several people about several possible projects connected with this. But this one was really interesting. What David was proposing was looking at the LCA of reusing these panels, how much energy it took to refabricate them, transport, and store them, compared to using, light gauge steel covered with chipboard for the interior partitions. And I thought that was like a really interesting question, which I hadn't really thought about. So he did the study, and I just picked some highlights from this. I know there's still a little bit of work to finish it off, David, but you got the results, at least this far to me. That's right, about 3 days ago, which is great. And it was actually incredibly encouraging, as you can see, is that there is definitely a decrease in global warming, acidification, and smog potential. And if carbon sequestration by biogenic carbon is included, it's a 704% reduction in global warming. And there are other things to consider, like the fact that you'd have more reduction if the mass timber weren't so heavy compared to, light gauge steel frame, and some other considerations that I won't go through in detail. And I'd like to say that if you have any questions about this, David is here to answer them, right? Which is great. Anyway, we're very excited that actually came, and I forget when I spoke to you, it was quite a while ago. So I've been waiting for these results, hoping they would be positive, and actually showed a positive story with the carbon. So we're going to make this whole story into a case study that will eventually appear on the website. It's not, again, so much, there have been research projects within it, like David's project, but it's really a case study of how a research project can have another life and teach us lessons about what else needs to be done. Okay, the next project is the house prototype, which you've already heard something about. And I've been working on this project for way too long, so I presented it at least 4 different cycles of these, so I'll try not to go over the background too much. But I've been working on it with Mark Fretz and with Jason Stenson, and by working on it, you'll see that the people actually working on it were mostly not me at all, in terms of actually constructing it, but I have been working on this project for some time. So this has been funded a little bit from Wood Innovation Grant money from the U.S. Forest Service, but mostly from the Economic Development Administration Build Back Better Regional Challenge Grant, which actually funded us to do 2 prototypes. And the first one is the one that you're going to see in the lab. And the project was originally based on work we were doing with the city of Milwaukee outside Portland, where they were proactively up zoning based on Oregon's HB 2001, which essentially got rid of single family zoning in any community over population 10,000. So they were looking specifically at cottage clusters. And we were looking at designing a little mass timber unit for cottage clusters. And we had one time thought this might be volumetric, but in talking to William Silva at the very beginning of this project, who is here, who was like, yeah, for this kind of thing, you got to go flat pack. It's for small infill sites and it could also be for ADUs. And so we started thinking about it as a panelized project. You know, mass timber can compete on cost with concrete and steel, you know, above 5 stories. William has a number of case studies that show that. But trying to get mass timber to compete with light wood frame has been really challenging, right, at smaller scale. And the question might be like, why would you want to compete with it? Well, this is the argument we made for the EDA grant, a kind of forest to factory argument that you can create you know, jobs all along the supply chain, particularly in rural economies, promote forest restoration, products that can be used in mass timber, increase demand for mass timber, and through prefabrication, make mass timber houses more rapidly. It also makes a product that is more thermally, seismically, and fire resilient than lightwood frame, right? Lightwood frame, you get one ember in, the whole thing goes up like kindling. So seismic, it does way more, but you also are unlikely to have, you know, finishes on the inside like chipboard that are going to crack and break. So there are a number, and thermally, it makes an incredibly tight thermal envelope. Okay, so that's why we wanted to do it. Which mass timber? Well, we wanted to use mass plywood because really most commercially produced CLT in the US and Canada is about 4¼ inches. There is some that's being made thinner, but not in big quantity yet. That's a lot of fiber. So with mass plywood, we realized we could use 2-inch and 3-inch panels. And the 3-inch panels are super strong and stiff, which is why they were used in the LA lateral force testing project. So we decided to do that. And the project uses 3-inch exterior panels and 2-inch interior panels. So as I said, we started working with the city of Milwaukee, and they were looking at what's called middle housing, you know, anything somewhere between single family and multi-story, but also really middle class housing, on the theory that even middle class people with jobs now cannot afford housing. And again, it's one of the reasons they started looking at cottage clusters as a way that you could have a little house of your own, but still make it affordable. So this is a little 2-story, 2-bedroom house we developed, really based on their code in terms of height and setback. One of the reasons we based it on a concrete floor versus a raised floor was to try to keep the height down as much as possible, because a lot of these, both ADUs and cottage clusters have 20-foot height restrictions. We're actually just over that. We'd have to flatten the gable a little bit to get it down. And you can see it's a pretty simple unit, half bath, and bicycle storage at the entrance. This is Oregon, gotta have bicycle storage. And dining and living room downstairs, and 2 pretty similar bedrooms upstairs, full bath, washer, dryer, linen closet. So as I said, we wanted to make it flat pack, and we were trying to be super, super efficient about the use of the material. We actually now know we were maybe too efficient in the use of the material, and that actually it might have been better to use a little bit more material and have a few less cuts and a few less pieces that we have to put together. And originally, we had thought that we were going to do this as flat pack with panels with insulation and cladding, and already on them. And what that meant was that essentially all the connections had to be done either inside or within the panels. So we worked with our engineers to develop this kind of interesting seismic connection, which was actually within the thickness of the panel. You're going to see it on the tour, which is actually pretty simple. It's a threaded rod with bolts at either end. But one of the things we realized even before we started building is we were pretty sure that in the end, we're probably going to go with a flat pack, which is just panels, which assumed insulation and cladding in the field for a variety of reasons. One is that we could do the connections on the outside, which is going to make it much easier. For example, we can use Simpson straps to attach the top and bottom floors and other standard components, and other things that Jason is nodding, yep, things that would make it much easier, because Jason was very involved in this construction process. So, you know, most of you know, we relied on our BSA machine to do a bunch of the prefabrication. This is actually prefabbing a different project, which I'll just talk about for about 30 seconds at the end. But you can see Jason and Dale using both analog and digital tools, right? And you can see but the incredible precision they were able to have, which allows the windows and doors to fit in extremely tightly. And I think I showed this project a couple of years ago, but Jason and Mark worked up this thing that you'll see there called the energy shutter, where they, instead of doing triple pane aluminum windows, which are pretty expensive, and we didn't want to use vinyl because we don't like them, they developed a third panel, which is a polycarbonate sliding panel, which provides both insulation and basically works as a kind of privacy curtain, which you'll see. But they did blower tests and other things, and these things are incredibly tight versus, in a frame house. And this is it going up. This is a 30-second video. It took a little longer than that. Right. But you get the idea. It went up pretty quickly. Of course, we do have some gantry cranes, which were extremely helpful in putting the thing together in the lab. And we didn't actually obviously pour foundations. We attached it to our strong floor, which has attachments every 4 foot on center. The second one, we're going to put an RFP for a contractor due, and that's going to go outside on a similar pad. Inside, we're going to be doing some structural testing because we know that 3-inch MPP is not in the code. We're going to have to do some performance testing to have some data for building departments to accept this. But we're not going to put out the RFP until we go through this round of optimization, where we think we can reduce the number of pieces to put together, reduce the amount of steel in the connections, and simplify the construction process a little. So I'll just give you a quick tour of the house because you're going to see it right in person, or whatever that is. This is actually before the doors went on. And this is what it looks like inside. We furnished it with IKEA furniture at the request of our Oregon Mass Timber Coalition communications crew, which thought we should show like what it looks like. And since then, I know that the TallWood staff has been using it as a conference space, as a lounge space. So every time there's various dogs that seem to like hanging out here. Anyway, but you can see what it looks like with some furniture. This is as you go upstairs. That linen closet acts like a cantilevered piece of decking, which I find very entertaining. You can see here the polycarb sliding over the window in the distance. And we also used some clear polycarbonate between rooms on the upper level. We tried to use the gable roof to kind of open up the upper level, and between the bedrooms and between the bathroom, you can't quite see it, or the upper bathroom and the hall area. This is the half bath on the lower level, and the upper bath. The upper bath uses clear polycarbonate as the surround for the bathtub. We were trying to be consistent. You can see that we have big skylights. Actually, the skylights are not that big, but we've got angled plywood to try to enlarge the amount of light that's getting in. And you will be able to see this when we go to Emerson. So the last thing, I'm not going to present this time. We'll have more to say about this next time. We've presented this before. This is a facade retrofit project, which the EDA is also funding some prototyping for. So with a Wood Innovation Grant, we did a 1-story mock-up and then 2-story testing. And the EDA is going to allow us to do a 3-story mock-up and structural testing, which we're going to be putting out an RFP for quite soon. So the idea of this was based on a project in the Netherlands called Energy Sprung, where they'd go in and scan a facade, construct a new one in the factory with a lot more insulation, and apply it to a building with windows without basically disturbing the residents. So the DOE, the Department of Energy, had some idea that this could be done with CLT. We thought maybe it could be done with MPP, and we could do seismic retrofit at the same time on the West Coast. So this is designed for 2- and 3-story light wood frame, multi-family buildings up and down the West Coast that are desperately in need of both energy and seismic retrofits. And again, I don't want to say too much about it now because we don't have anything really new to present on it, but we should, next year's symposium, we hope to have the second prototype of the house and the 3-story version of the facade retrofit. For the house, we have a commitment for a pilot project of 4 out in Eastern Oregon with a group called R3 out in Burns. And we're hoping to find, we've been talking to a number of contractors about getting a pilot for the retrofit. And we know, and I'm sure many of you know this, that it takes a number of iterations, right, before you can really optimize these things, really figure out the best way to construct them and really what the costs are. But we are hoping in both cases that we can do something that through prefabrication and digital workflows will produce something that is actually affordable, for that middle housing group. Thank you. So guys, I'm going to stay right here, right, Parker said, because I'm just going to switch hats for a second here. And I'm going to field questions about any or all of the work from Corey, Chevy, who's not here, Siobhan Rockcastle, Dylan, Jason, or even me. So if there are questions, anybody have questions? Mhm. Yeah, and there's one right here, and there's another one. So do you want to, is somebody going to pass? Right here? All right, right. There's one here. There's a whole bunch of them, I think. Mhm. And when
Probably,
you ask a question, can you tell us who it's for?
I believe it's you.
Oh, okay. Well, that's convenient. Yeah.
Yeah. Just curious, it's probably listed somewhere, I haven't noticed it, but the R value of your 4-inch, 4.25-inch panel.
Well, we're using a 3-inch
Or
panel.
3-inch, what is
Yeah, I
the
mean,
R value?
you know,
You said it has good or a decent insulation value.
It's going to be combined with a whole bunch of rigid insulation on the outside.
Oh, okay.
Yeah,
all right,
and
all right.
hopefully, what we're hoping for is wood-based insulation, which is made in Europe. Finally, there's a company in Maine that is making it and is hoping to open a plant here in Oregon. So there'll be a ton of insulation outboard and on top. And the second iteration that we make outside, that is going to have the insulation cladding on it.
Okay. all
Yeah,
right.
so that we can do the
Depending on
thermal.
Just the R value alone.
Oh, yeah, alone, yeah, it's
But
very.
you don't know what that is that you're adding to offhand? I'm just curious.
Yeah, and there's a lot of research that needs to be done in this, because right now the only credit you get is basically like R1 per or 1.5 for an inch of plywood or something like
Okay.
that. But their Oak Ridge National Laboratory is doing some studies now with the CLT cubes, because they believe through, experience that you're getting much more insulation value than that, but we don't have any data on it. So that, building departments aren't going to accept it yet, but that's another area for research actually, is how much, if you do an all mass plywood or all CLT house, how much extra R value do you really get out of that,
Right.
rather than just the wood product?
And what
know.
about air circulation throughout the home? I mean, is it sealed tight or you having
It's,
good
yeah,
ventilation throughout?
it's both sealed tight, and we have an HRV unit in it.
Oh, okay.
Yeah.
So.
Yeah, to
some
circulate air.
Fresh air supply.
Yeah, and when you tour the house, we'll point out where that is. Yeah,
Okay.
there's the HRV, right?
Right there.
Yeah, you can't see it. We have it concealed, but we can show you where it is. Yeah.
All right.
Mhm. Yeah,
Great. Thank you.
sure. And there's also windows that open, right,
There
which
you
is very important,
Can't
right?
forget
Right.
that. Thanks.
Okay, so other questions? Mhm. Mhm.
Yeah, how did you conceal the MEP in the walls?
The what?
Mechanical, electrical, plumbing.
Okay, so we spent, I think what can only be described as an ungodly amount of time discussing this. So, heat pumps and mini splits are not cheap, and everything about this is we're trying to drive down the cost. So this is absolutely not my area. Really, Jason, you should be talking about this, but I'll give a very brief answer anyway, which is that we actually are using electric resistant heating under the windows, the HRV unit to circulate hot air, and a little air conditioning unit that is under the stair. And we think that is going to do it because of the very tight thermal envelope. And these are incredibly cheap, right? And we think it'll be super efficient because of the incredibly tight thermal envelope. We're not testing it inside Emerson for obvious reasons, but when we do the second prototype outside, that's one of the things that Jason and Mark and Dale will be testing is really how much how tight that envelope is, and over a certain period of time, like how much energy does it actually use? Yeah. Anything? Yeah. Mhm. Maybe questions for someone else. What was that, Frank? Yeah, and this is Frank Paul's from Unbrick, which is built CLT modular housing in the Netherlands and in Europe, and they have much more experience with that than we do in the US. Yeah, so that'd be great. Mhm.
I noticed when you showed the bath, it just looked like you had bare MPP in the bath.
No, we actually, that's what it looks like. I could actually go back to it, I think. Let's find out. Yeah, it's actually covered with clear polycarbonate. The same thing that we used to be, sort of on the upper level and the clear stories there. Yeah. We decided to be materially consistent. So, and we thought it was kind of cool that you could see the plywood through it. Mhm. We haven't started worrying about that yet. Mhm. I'm looking at Jason, who looks like he wants to answer that. The skylights are operable. Yeah. Mhm. We haven't been running water in it yet, but that's one of the things we'll probably be looking at some point outside. But yeah, no, it's sealed, ventilated. We'll hope for the best. Yeah. Mhm. Any other questions? There's something in the back, and I want to say there were a bunch of other presentations that you could be asking questions about.
Hi, is there a special drive behind using the mass ply panel instead of the CLT?
We used it because we could use a thinner panel. Yeah, because we could use a 3-inch panel and a 2-inch panel. And it's actually stiffer and stronger than a 3-ply CLT panel. So we used it to minimize the amount of fiber. We also had another motivation, which is that, it's a local material in Oregon made by a local company, and a company that developed the product using, with the help of a lot of faculty at OSU, including Ari, who is here, who did a huge amount of work with them, and Andre as well. So we do have a connection to them, and they're local, but really we chose it because we could use very, very thin walls and floors. Yeah. Mhm. Mhm.
I think it's heavier and denser. Then talking about the LCA, then doesn't it cost, or would it be more?
Sorry, I can't quite hear you.
Sorry, it's denser and heavier. So, and it uses a lot of glue because it's LVL. In terms of LCA, wouldn't it be, I want to question that if it's better than the framing.
It's because it uses veneers, right? And one advantage to using veneers is that they get about 70% usage out of a log versus lumber, which gets maybe 50%. One of my students did a big study about this, Ethan Bloom, who's here, did a look at comparing CLT and MPP, and not just original log usage, but structurally how they compared in terms of how much material you would use versus the other, and how much wood you would actually save. So we worked with Ethan on that study, and think that the MPP is actually a more structurally efficient way to go, and also more efficient in terms of just fiber usage and log usage. Mhm. 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 Mhm.
This question's for Dylan.
Oh, okay. Where's Dylan? Mhm.
I was curious, are you using a standard resin or glue for your curling panels, or are you using something different?
Yes, we're using a standard PUR adhesive that is, well, in Europe, it's a Henkel adhesive, but it's a normal PUR. Also now apparently 99% bio-based, but I don't know if I believe that. We would have to ask Ari about that. It's very standard. I guess it's not so standard in North America yet for CLT. But yeah, and the reason that we use that is because it is activated by the moisture. So it is an ideal situation for gluing with high moisture, but we are still gluing outside the regulations, which means that when we used this self-shaping process for making CLT in the previous projects, we have to apply for the equivalent of like a sort of extreme performance-based certification, because we're way outside the moisture rates and the moisture differential between the two boards. But in concept, it works well because it's actuated by the moisture.
I have a question about the hypothesis that this could actually help create jobs. I see a lot of tradespeople that would still be involved in the construction of this, and yet there's some efficiency in the framing trades. I'm wondering with this new RFP, would there be any kind of metrics where the contractors that you would hire could start to unpack the labor conversation? Because of course, for this to go mainstream, there's going to have to be some benefit to the industry and the tradespeople, whether it's training and innovation or just not necessarily automating their livelihoods. So it's just an interesting element of this conversation I was curious about.
Right. I went back to the YMAS timber. This is a diagram we've used, which really talks about this kind of forest to factory argument we made for the Build Back Better Regional Challenge is that, and you remember when Ian was talking about the smart forestry jobs, the idea is we're trying to create new high-tech, well-paying jobs all along the supply chain, starting within the logging industry, using more robotics, more, high-tech ways of doing things there, but also in manufacturing where, all the machines now are computer controlled and involve more workforce training for that. As well as, putting these together in the field is not rocket science, but it is different from light wood frame, so it involves some training. So, one of the things we're working on, and Julie Purse, am I pronouncing your last name totally incorrectly? Is here from Portland Community College, who was working with the port on developing, workforce training curricula, mostly based on the construction trades and manufacturing ones. But we also have a partner in Washington who's working on workforce training curricula for the forestry and logging area. So that's actually for all these grants that we are working on, that it's a huge component of what they require is workforce training programs and, trying to get these out and creating new jobs that are less, manual labor and more high tech. And theoretically require more skills and pay better. Yeah. And that would attract younger people. Anything else? I think.
I had a couple
Oh,
of
yeah.
questions.
Oh, sorry. Hi. Right.
All right.
Mhm.
I was curious where you ran your electrical and plumbing. The chases actually cut into the panels. Does that affect the structural value of the panel, or is it?
The plumbing,
And
and you
elec-
probably can see this in the plan, is all confined to one zone. We have actually, it's the one hollow wall we have. It is behind the two bathrooms and the washer dryer in the kitchen. So we do have a hollow wall there. But we're actually using a wall hung toilet, which is actually hung off the mass plywood wall behind it.
And-
But we do have that one hollow wall for running the plumbing. Then the electrical, again, we spend God knows how long discussing these things, but like in a lot of commercial buildings like PV Hall, which is an institutional building, where they leave a gap between CLT floor panels for running electrical. We did the same thing. So we do have an electrical chase running through the gap between the two floor panels.
Mhm.
And then we also have electrical running around, and you'll see this in the house. We have a baseboard that basically has electrical conduit in it, and we have it also running in some of the ledger beams at the top. So yeah, I mean, we spend an ungodly amount of time trying to figure out the best way to do this, given that we don't have hollow walls, right? Like
Right.
everything about it was different. Like, how are we going to do that? So a lot of it, again, was like, how can we do it so that it's attractive and looks organized, but also that it's not expensive?
Right.
Again,
It sounds
again,
like they're still accessible. I mean, you can
Right.
remove the baseboard.
Still have like plugs everywhere you need them.
Mhm.
Yeah, which is the idea. Yeah.
And the other thing is in rural applications, it might be a little difficult or a little more costly since you require cranes and special transport to, to build these structures.
What we're hoping, and we're going to find that in the second iteration, is that we think you could probably do this with a what's it called? A telehandler. I always forget the second part of that, a telehandler rather than a full-size crane. So we made the parts, it's one of the reasons that we decided to do platform framing instead of balloon, was that to make the parts not too big,
Right.
no bigger than 8 feet. So we think that we can do it that way. So when we do the second one outside, we're not going to have the overhead cranes. And we're going to find out, in fact, if you can do it with a combination of forklift and telehandler rather than a big crane.
Mhm.
And a telehandler is something you can, rent at U-Haul and use pretty easily. So not people have done it. I myself would not do that. But
Right.
there are people who definitely do that. So I think that the whole idea of this is that these could be produced efficiently as a kind of kit of parts in a factory and shipped out for people to do. But it's also, if the files exist, a contractor could just work with somebody who has a CNC machine, fabricate them themselves, order the steel and also put it together. So we were trying to keep it in a way a little bit low tech so that it could be done more efficiently in a factory where you get a pack of these things shipped out. Nothing's wider than 7'10", right? Shipped out to the field with a whole stack of steel connections and screws, sort of like an IKEA thing, right? Where you could just put it
Yeah,
together,
everything's labeled and because you got to order a construction.
right? In 3 languages that nobody quite understands. Yeah, no, we
Mm.
But the idea was that it was supposed to be flexible for those kinds of applications, but we're going to find out, constructability is a big question. So we'll find out a lot from the second, prototype out in the yard. We'll find out even more when we have the first pilot project going out, which is in Eastern Oregon in Burns, where there isn't a lot of infrastructure. Yeah, and we want to see what we need to adjust, what we need to think about as we go through these different stages.
Okay, great. Thank you.